All right, this is going to be a lesson on 1.3, Newton's second law. So the do not question says, what is the difference between a balanced and unbalanced force? This should be something you guys remember from the previous lesson, right? So a balanced force is when your net force is 0, and an unbalanced force is when your net forces are not 0. So let's take an example, this image. Right, clearly, again, we have a force to the left, which meaning it's a negative 300 newtons. The other side is positive 300 newtons. So 300, negative 300 plus 300 gives you a net force of 0. So, and on the bottom, your forces on the bottom are unbalanced. Right, you have a negative 300 Newton force plus 100 Newton force, and that gets you negative 200 newtons. And so your net force on the bottom is negative 200 newtons. So the forces on the bottom are unbalanced, and the forces on the top are balanced, right? And so your balanced forces again is when your F net is 0, and unbalanced is when your net force is not 0. It is unbalanced. This is just a review again. Balanced forces, net force 0. Unbalanced forces, F when F net is not 0. And again, your F net is the sum of all your forces. F net by itself is not a force. Let's take a look at the simulation. So it's very important to understand two types of terms. The first term is something called acceleration, and the second type of term is called constant speed or velocity. So let's take a look at this. So I want you to pay attention to what's happening to your speed when your net forces are unbalanced, right? So my net force is unbalanced right now. My net force is not 0. My net force here is 56 newtons. As you can see in the middle, the sum of all my forces is 56 newtons, right? Because we have an applied force of 150. And so my applied force here, I have an applied force of 150 newtons to the right. And my frictional force is 94 newtons to the left, which means that my net force here is 56 newtons to the right. Again, this is an unbalanced force, right? These are unbalanced forces. These are unbalanced forces. Your F net is not 0. And well, what happens when your forces are not 0? What happens when your forces are unbalanced? Take a look at your speed and your acceleration. Well, when your forces are unbalanced, your object starts changing its motion. It starts, well, one example is that it starts speeding up. Right? My speed definitely changed. And let's go back to the beginning. Right? Let's cause an unbalanced force here. Right? And so as you can see, actually, my speed is constantly changing now. It's changing. So when my forces are unbalanced, my speed changes, my velocity changes. And my acceleration, and again, this is a term that we haven't talked about yet, we haven't defined it yet. Acceleration is, I now have an acceleration. If I'm changing changing an object's motion, I have an acceleration. Well, let's take, for example, something that, what happens when my forces are unbalanced? I mean, rather, when my forces are balanced, which is this situation I'm showing you right now. So what happens when my applied force, when I make my applied force here, and this person is pushing on this block with an applied force of 94 newtons, and there's a frictional force to the left of 94 newtons as well. And so my net force here is 0, right? Because this is a negative force because it's going to the left. So my forces here are balanced, right? These are balanced forces. These are balanced forces. And so what happens when my forces are balanced? Well, let's see. Let's continue this simulation. Does my speed change? No, my speed does not change when my forces are balanced. My speed is constant. My velocity is constant. Do I have an acceleration when my forces are balanced? No, there is no acceleration. My forces, when my forces are balanced, when my F net is 0, when my sum of all my forces is 0, my speed doesn't change, and my acceleration is 0. Whereas when we do have a net force, right, when our net force is not 0, our speed does change, and we do have an acceleration. All right, let's go back to this. So here is a summary of what happens when your Fnet is not equal to 0 and when your Fnet is 0. Feel free to pause the video to read the entire thing because I'm not gonna repeat it. It's too much for me. It's too much. Now, let's take a look at this image. The image below shows a compiled snapshot of the same object over several seconds in time. Right, so at one point in time, it's over here. At another point in time, it's over there. At another point in time, it's over there. And so this is equal intervals. Like, and let's just say, for example, I don't know, it's like 1 second after each snapshot. Again, this is the same object, just multiple images, multiple pictures taken over time, and then combined into one image. And the question here is, describe whether this object is moving at constant speed or is it accelerating, right? Is it changing its motion? And the answer here is that the objects are moving at constant speed. Right? The objects are moving at constant speed here. And the reason is because, well, you travel the same distance every interval. Each point in time, each amount of time, equal amounts of time, I'm traveling the same distance. And I can say that, well, my velocity here, my speed here is 1 meters per second, and I'm making it up, by the way. This is not true numbers. And my velocity for the second point in time is also 1 meters per second, and so on and so forth. And so I travel the same distance every interval. Each interval, I'm traveling the same amount of distance. And I can say that my object is moving at constant speed, constant velocity. Well, what about this image, right? What about this image right here? Well, you can tell, is it moving at constant speed or is it moving at, or is it accelerating? And if you think about it, you can clearly see that the distance between each interval, this object is traveling a greater distance each second, right? And so because it's traveling a greater distance, we can say that this object is accelerating. This object is accelerating. It's traveling a greater distance every second. It is accelerating. An easy way to show this is if you look at the bottom bricks. Look at the bricks on the bottom. And so this is accelerating, or rather, this is constant velocity, right? There's an equal amount of bricks passing by you each second. right? We're traveling the same distance each second, so we know we're moving at constant velocity here, right? An equal amount of bricks are passing by you each second. Whereas when you're accelerating, more and more and more bricks are going to pass by you each second. You see more bricks. Whereas when you're traveling at constant velocity, there was an equal amount of bricks passing by you each second. So about Newton's second law, and it's something about Newton's second law. The acceleration. You're given a formula here. This is the second formula you guys are going to learn in this class. Is Newton's second law, right? So the acceleration in object fields is equal to the net force acting on the object divided by the mass of the object. And again, acceleration is the change in velocity over time, right? That's the definition for acceleration. As a definition. So Newton's second law basically states that an object experiences acceleration when an unbalanced net force acts on the object. Right? This is when your net force is not equal to 0. Again, a true definition of acceleration is the change in velocity over time. That's very important. So let's do a practice problem. And let's do a practice problem here. What is the magnitude of the acceleration this block feels? The block has a mass of 5 kg. So when we're reading this problem, it's very important that you guys figure out, well, what do you know and what are you solving for? Right? So the question is asks you for, well, what is the magnitude of your acceleration? Right? What is the magnitude of your acceleration that this block feels if the block has a mass of 5 kg? And so you have two more forces here. You know that the force 1 is 12 newtons. You don't know what force is acting here, but you know that it is a force. And you know that force is 2 newtons. Now, if you guys were paying attention, well, this force is acting to the left, which means that my force 1 here should be negative 12 newtons. Negative 12 newtons. Right, so the formula we have is A is equal to F net over M. My F net is the sum of all my forces. The sum of my forces. So again, well, the definition of the sum of all your forces is that you're going to add up all of them. So my acceleration is F1 plus F2, negative 12 plus 2, divided by M, which is 5. And then I have negative 10 over 5, and that gets me negative 2. And the unit for acceleration is meters per second squared. Right, this is your answer. Again, the unit for acceleration is meters per second squared. Let's do practice problem 4b. The net force acting on these two blocks is 20 newtons, right? So you have a net force. Net force is 20 newtons. The mass of object 1 is 2 kg. Mass of object 2 is 3 kg. And you want to know, well, what is the magnitude of your acceleration? Yeah, by the way, when the problem tells you what's the magnitude of acceleration, they just care about the a number, right? The size of something, the number of something. They don't care about direction. So when they say magnitude, they don't care about direction for your answer. They don't care about direction for your answer. That's all the magnitude means. It doesn't mean anything else. So again, you're using this formula. Now, the important question here is, what are we using for M, right? What is our M here? Well, our M here is our total mass. Our objects are connected. Our objects are moving together at the same time, which means that we have to add up both our masses. They are moving together, which means they feel the same acceleration, they feel the same force. And so we can, when we do 20 divided by 5, we get 4 meters per second squared. Let's do 4C. Let us do 4C. Diagram below shows a horizontal 12 Newton force being applied. So my applied force here is 12 Newtons. Initially at rest. So block A has a mass of 1 kg. I'm just going to write mass 1 is 1 kg. Mass 2 is 2 kg. And the magnitude of acceleration is, block B is what? So what is A? Now the question says, what is the magnitude of acceleration on block B? The thing here, the very important thing here, is to realize that these blocks are moving together. And if these blocks are moving together, they feel the same acceleration. They are moving together. They are connected. You might as well get rid of this boundary and treat them as one object. So when you're solving this problem, you do not solve for the individual mass, you solve for the entire moving object. Right, so when we use this formula, when we use F net A is equal to F net over M, we have to be careful and say that A is equal to 12, which is my F net, right? Because the only force being applied here is my applied force, which is 12. And my mass, I have to do my total mass. I have to do 1 plus 2 gives me 3. The object is accelerated. The objects are accelerating together. They are moving together. They feel the same acceleration. And so my answer here is 4 meters per second squared. .4D is a pretty difficult question to understand. So you have a 4 kilogram object, right? So let's say mass 1 is 4 kg. And you're accelerating it at 3 meters per second squared north. So the acceleration of object 1 is 3 meters per second squared. By unbalanced force. So you have a force that's being applied, right? This unbalanced force that's being applied here. And it's being applied on mass 1. The question goes on to say, well, the same unbalanced force, right? So you have an equal unbalanced force acting on another object, a 2 kilogram object, right? So my mass 2 is 2 kilograms. And how fast will I accelerate this object, right? What is this acceleration this mass 2, the second object, feels from the same unbalanced force? Well, to first solve for this problem, right? Because we don't know what our force is. If we try to solve for the second acceleration, we don't really know what my net force is, right? We don't know what my applied force is. We don't know what my unbalanced force here is to solve for our second acceleration. But what we can do is we can first solve for our net force, right? We can actually just solve for our net force first. Right, so I can say that the acceleration of object 1 is equal to my net force, which is really just my applied force here. There's no other force, over m1. And so a1 is 3. My f net is what I want to solve for. M is 4. I multiply by 4 on both sides, right? And I get 12 newtons is equal to F net. All right. And so that's my net force. My net force is 12 newtons. Okay. So A2. So now that we have our net force right now, now that we know what my net force is, I can now solve for A2. So my net force is 12 newtons. My mass of the second object is 2. And my acceleration is going to be 6 meters per second squared. All right. And that's our answer. There's actually another question I want to go over on your homework though. Let's go over it real quick. I want to go over question 3. Let's make this a little bit larger, right? It's okay. So you have a 5 kilogram mass, right? So you have a 5 kilogram mass, 5 kilograms. Box is acted on by a force of 67 newtons east, right? So you have an applied force of 67 newtons east, and you have a frictional force, which the problem says, and you have a frictional force of 17 newtons west. I want to write that as negative 17 newtons. Question says, well, what is the magnitude of your acceleration of your box? Well, we have to use this formula. A is equal to F net over M. So A is A. Now, F net is, again, the sum of all your forces, right? So what we're doing here is we're adding our force through friction plus our applied force divided by M. So A is equal to negative 17 plus 67 divided by M, which is 5. Negative 17 plus 67 is 50 divided by 5. And you get 10 meters per second squared. And that is our acceleration. All right, that's going to be the end of this